Welcome, everybody. I was laughing a bit when Gyula was talking about his system because I'm old enough to know that around 2000, if you didn't write a PHP framework, then you were not an engineer. Of course, some people said that if you are using PHP, you are not an engineer, but it's a different story. So I created my own system called Pairflow, and this talk is about not just the journey, but some of the kind of foundational knowledge which was important to build it. Just a few words about my background. I started as a backend engineer. I was working at UC Bitrise. I was leading the whole engineering there at some point. We were building services which served like 100 million people a month. So I have a lot of experience with high available and high scalable systems. And I have a lot of experience with building teams. And nowadays, I'm very passionate about these agentic engineering topics. But I'm mainly interested in how it can be used in real software delivery. So I'm not a vibe coding coder. And this part of the story, maybe a few of you know that I'm responsible for the program at the Craft conference. And this journey started in last, maybe August, somewhere, when I started to do the research for the conference. And at that time was kind of the biggest hype around this vibe coding. So it was very, very hard to figure out, what is real, what makes sense in the real engineering settings, what not. But around September, there were a lot of early signals that very decent engineers started to put together reliable workflows. Of course, at that time, we didn't have Opus, but still they achieved very great results. So this was one of the reasons why I really started to study this space. And the way I kind of interpret is that, the old way of doing or using AI is this prompt by prompt type of usage. But now we have the opportunity to delegate a lot of work to the AI. And in this setup, what is really important that the system that you build around the models is much more important than the model itself. So I really like this term, build a system that builds the system. And from now, I think a huge attention of us should be going to building that system around our code base. And just to provide you a quick landscape about the different levels of using AI. There was an article from Dan Shapiro, and he kind of coined these terms. And we started with the spicy autocomplete. Then we can say we have the coding intern, where we delegating small stuff. Then we started to delegate more, but still we were working inside the loop together with the agent. And there is this L4 and L5 level. L4 is when you kind of start checking everything that the AI is doing, but you really start delegating a huge chunk of work to the LLM. And this is kind of like the first level when you really delegate to the LLM. And I guess many of you is aware of the trend that nowadays the agent can do more and more autonomous work. So I decided that this should be my main goal, to get at least to this L4 level. And the L5 level is this, what is called nowadays this code factory, where you absolutely don't care about the code. I'm not there. I'm very curious how that word looks like, but I still need to do a lot to get there. So just to start the discussion, so this was kind of like the very naive approach in early 2025. There was a lot of buzz that you just give a bunch of MCP to the agent, and then you give a huge task, and the agent will figure out everything. And this was not really working well, and many companies just burned themselves trying to work this way. And the reason why this approach is kind of very fragile is that if you give too much context to the agent, then it won't work. If you give too many tools, then it is hard for it to decide, which one is good, which one is not good. Another big issue is that agents are not necessarily reliable following your request. You might run into these cases as I run into that, oops, I deleted the test, or oops, I removed the test. So there are many ways that you cannot trust one agent. So what we actually need, so if you want to delegate more work to an LLM, then we need more control, which is kind of like a bit like paradoxical. And this is where this term called harness comes to the picture. So you really need to create a system around the agent which steers the agent to the right direction. And I highly recommend this article on this slide. So if you are not aware of this article, I think it's a very great summary about harness engineering. I don't want to go into all the details because it's like it could be like a multiple days discussion, and we would need a lot of beer. But what is really important that you need to create a system which makes the work steerable, observable, and correctable. And what is one important trait of a good harness is that this way you don't delegate a big work to just one agent, but you kind of decompose the workflow, and only small bounded works goes to one agent at a time. And usually when we talk about bounded work, which are safe to delegate, usually we talk about like we need to have a role, which is usually what we call like the agent. Usually it includes, what type of skills, what type of tools, what type of other information or guidance we provide to the agent to enable it to make a great job. And of course, we have an input, we have an output, and we need some kind of gate which makes sure that it checks the result, it routes the next workflow item, and of course it can do much more. So we need very clear boundaries and we need verifiable outcomes. And this is how we can create repeatable work, and this is how we can recover if the agent is going to the wrong direction, because it will. So if you try to work this way, you will notice there are so many ways that an agent can go to the south. But the good news is that in most of the cases, it's not the agent, it's us. So we were not providing the good guidance. Maybe we were not empathizing well with the agent, because sometimes it's very, very hard to deal with this, what is called this jagged intelligence, that sometimes it can do like super great stuff, and then something seems to us like a very small issue, and the agent just cannot overcome it. So it's, and sometimes it can be very, very frustrating. So to give you an example, in my tool, which is called Pairflow, now I have these three roles. There is an implementer, a reviewer, and a meta reviewer. And I have an orchestration layer which kind of passes the ball between them. And each role has a very clear purpose, and the boundaries around them are absolutely clear. And to highlight a bit what I mean by this input, role, output, for the meta reviewer, for example, the input is all the findings coming from the reviewer. The role is that it needs to deduplicate those findings, need to classify them. It needs some extra checking as well from a system fit perspective. And the output is kind of like a decision, whether that work is accepted or it needs to be reworked, or it is okay to go for human approval. And what is like maybe a small thing in this slide, but it's very important that the agent is not making a decision here from a workflow perspective. Only the gate is making that decision, and the gate is running in the deterministic layer of the tool. And this is very important, because otherwise, I have many friends who are kind of creating something similar because they run into this issue that they have a very specific instruction set that you need to follow these steps, but the agent is not following, or they decide, as Gyula mentioned, that, I just thought that step is not so important in this case, so I just skipped it. So what is really important that the agent can be non-deterministic, but the workflow should be deterministic. And this is how you can really create that control that I was talking about. So the workflow should own like the state of the workflow, the routing between the different nodes of the workflow. The gates should be owned by the workflow. And of course the recovery, because in many cases the agent can go into the wrong direction, and it's very important to get back on track. Because otherwise, if an agent is working like 5-10 hours, if at the first step it's going to the wrong direction, then it won't reach to the place that we would like to. And the way, for example, in Pairflow this works, the orchestration is a CLI API, which is, by the way, great because even from Craft code, or Craft agent, it is very easy to use. And I think it could solve some issues that, Gyula, you mentioned that you have nowadays with AI. So this core CLI handles the state transition, evidence checking. So, for example, if the implementer says that I promise I run the test, this is not enough. So it has to create an evidence file about running the test, and the orchestrator layer checks whether this is true or not. And there are some policy checks as well on that level. And this is how we can really steer the agent. And there's another interesting term which I don't really hear about in the mainstream. And maybe I just accidentally run into this way of working. I'm not sure about it. Even I'm not sure whether it's the right way to do it. But for me, it helped a lot. So if you think about, in many cases, so let's imagine that you create a document which is coherent, and then you want to make a logical change on it, and you ask the agent, okay, please do this change on the document. And what will happen that it changes the document, but it doesn't necessarily mean that it was like a full coherent transformation from the first state to the next state. And if you ask the agent, please check whether the document is coherent, it will find some issues and says, now it's fully coherent. Please check again. I still found 3 issues. And this type of loops are very, very important to get a trusted result with an LLM, because you cannot really rely on just one pass. And this, for me, was a big lessons learned, and this is a fundamental core of the system that I created, because in some way we can say that the harness is not just about the control, but it's about, so it should be kind of like a convergence machine, which means that so it means that we have the actual state and we have an ideal state, and we gradually get into that consistent ideal state. And this is why I kind of coined this term like gradual consistency, a bit similar to eventual consistency, because this was my experience that you cannot reach to a consistent state with one LLM pass. You need to do multiple steps. But what is really interesting, especially with these new models, which are like super capable, that they can really find some very interesting issues in a document, but they are not capable to find all of them. This is why you need to run this type of corrective actions in a loop. So this is how I see like the evolution, that initially we have the prompts, then we started to use agents, and then we started to create a harness around them. And maybe it's a bit too big verse to say that this is the next level, but I think it's a very important aspect to think about this convergence as well, because this is how we can really get to great quality. So I don't want to, I don't do like a real demo because it's quite slow, which is funny because we expect a lot of speed from AI. But running it for one specific task, it can be a bit too slow. But this is nowadays my general workflow. I have a discussion, like Gyula mentioned. It's super important to make sure that you very clearly, define what you want to achieve. Usually I'm just using, nowadays my mainly driver is Codex. I was a huge Cloud Code believer like 3 months ago, but Anthropic, I think, fucked up a bit. And nowadays I found Cloud Code in many cases not super reliable. So I just have a discussion with the LLM. In many cases, we are creating just interim documents to make sure that we are capturing those interim syncing steps. And at some point, we get to the point that, okay, this is what we want to achieve. Let's create a task file. Usually I'm creating a plan file, which is more task file, but for this way, I think the workflow is simpler. So I create a task file. This is how I create this bounded work that I mentioned. And then I run the task through Pairflow. This is kind of like an isolated small work. Actually, I changed the slides, so maybe this is an older version that we are seeing now. And then at the end, I'm still doing a review and testing it. And what is very nice that Pairflow can provide some help with that as well. And to give you some experience, how does it look like? So again, I have this chat in Codex. I just ask to please create a task file, then it creates a task file. You will see later that I have very special skills I'm using at these steps, which makes the whole system more reliable. And then I'll just ask the agent that, okay, now please run this task with Pairflow. And then through another skill, it just calls the CLI. It starts the process. So what is a very nice trait of Pairflow, and I highly recommend that you are creating something like that. Make sure that it's kind of agent first. So a CLI can be used by an agent easily. So it can manipulate the system without any help. So it kicks off the work. And I'm not sure how easy to see, but here's when you can see that we are going through some steps like the implementer has a run, there's a reviewer, the implementer. At some point, if you get to convergence, then comes the meta reviewer, and the meta reviewer can kind of override that convergence. It says, hey, no, you still need to do some work, and then it goes back to the implementer. And there are some nice features that from this interface, you can kind of attach into through the CLI into that session if you want. Sometimes, many people like Peter Steinberger said that you can develop kind of like a sense when you watch this stuff that whether something is going to the right direction or not. I kind of feel the same, that sometimes you just look what is happening, you somewhat understand that this shouldn't happen this way, and then you interrupt and ask the agent that, hey, what the heck is happening here? And also you can kind of open into this work tree with a button, so you can use your own favorite tool to check the results. So usually I still do some code review before I approve a work. And what is very nice that based on the specification files, I can generate some test scripts as well, which is not yet automated, but soon I will automate it. But it can really help to explain to me the changes, and even it can generate some scripts that you need to run in the browser, and it checks many of the functionality, whether the given task is really ready or not. So now we can move to a bit more practical stuff. So what was my process to get to this point? And in some way, it was very, very simple. I just wanted to make sure that I create trusted, reliable components. So usually when I felt some pain, then I turned into some reusable control. This was kind of like the process. Practically, it really is that in many cases when I did a part of the workflow, kind of the first time, then I did it manually. I kind of experimented how it is possible to effectively do it with an LLM. But I kept building first some subcommands just to make sure that I can turn that experience into repeatable way of working. And this way you can even build some trust, because you will learn when you are just like a monkey who is just pushing the next button. And when you get to that point, you know, okay, this is probably reliable enough. And this was the point when I kind of built those type of skills into the harness. And this was the process to make the harness better and better over time. And this is a good example. I will talk a bit about the specification, because at least for me, it was quite a big challenge. So for example, I ran into some issues that when I was so I tried to converge a specification to a good shape. I ran into issues that its convergence was very, very painful. So sometimes it was like 30 rounds. And I was stubborn enough to wait whether it converges. So it converged, but it was very, very painful. So I kind of started to investigate manually, okay, what the heck is happening here? Why this is so painful? And I started to understand which are some of the error cases, which for LLMs are very hard to deal with. And then I started to capture even those issues into a skill. And then now I'm just using this skill every day. And I'm literally, this morning, I was kind of building this into Pairflow. Or first I'm building the skill, and I plan to use it for like a week. And if it's working well, this will be the next big addition to Pairflow. Because right now I can kind of move one task through this funnel. But if this will working, that I will able to delegate the full plan to the system, and it will kind of decompose the task autonomously, and then it can deliver the whole plan without me. So as I mentioned, the slicing sometimes was very, very painful. So I identified kind of like three main issues in this topic. So one was that the specs start to diverge. This was the first big issue. And I realized that this is somewhat natural, because if you want to have like a solid implementation, you need some details. But if you add details to the specification, then of course the LLM will catch some inconsistencies, so it will ask even more details. So you refine the document, but it asks more details. And it was not very easy to overcome this situation, especially when the code base started to become more complex. The solution was an old trick, divide and conquer. So I started to make sure that I started to have a very clean structure for the plans. So I have the PRD level, which is only about the intent and the control model. I have the plan, which is kind of like a gap analysis between the actual state and the ideal state, and the sequencing, which is the list of the tasks which will be needed to close that gap. And then I just keep creating the task one by one. And even at the task level, it was very important that I created a template which is mainly focusing on contract boundaries, which means, types, database schema, how we are talking with different systems, so those type of issues, and no other details which could be considered as an implementation detail. Those cannot go into the task. But I have very clear contracts, very clear acceptance criteria. And it's very interesting that the model is capable to somewhat check those acceptance criteria even without running the code. Of course, this is not reliable, but still it can catch a huge amount of issues, even if you have those details in the task file. So the next issue was that I called the entanglement trap, that if there was too many constraints in a task file, then the LLM started to struggle. And after 8 rounds, it seems that we are good. We fall back to having like P1 issues, which is almost the higher level of kind of errors. So I needed to realize that kind of LLMs have an attention budget. So it's a bit different than the context window. It's kind of like how many instructions it can handle on a reliable way. And I needed a way to make sure that I don't have too many moving parts inside one task. So I kind of developed some measurement to deal with this situation. And this is where first this review spec was created. And I started to use it whenever I created a task. I ran this workflow, and the decision was always like split, refine, or approve. And this worked very, very well. So I was very happy with it. But then there was another issue I ran into, maybe not as many times, but quite a lot of time. Again, especially as the code base started to become more complex, so the task looked quite okay, and it looks ready to be implemented. But then during the implementation, some system connection type of details started to surface, like, I don't know, there's a bit different data model in that file than how the task expected. So again, actually, I went back to this review spec, and I started to add 5 more dimensions, which kind of measure this perspective. Actually, the code is, so I don't want to go into details because it can be boring, but you can access the scale on GitHub. But the idea was that some of those gates kind of measured the semantic alignment of the task with the existing system, and some others were about the technical grounding. And what was very, very important, that this aspect were taken into consideration when the task was generated, but still the task was not good because of this gradual consistency issue that I mentioned. So this is why in many cases I need to call this review spec like 5 times in a loop, and it takes 5 times to make to put that task into a good shape. And another important trick here is I really like this concept, like more compute is better result. So in many cases, it makes sense just to use multiple sub-agents, for example, with different perspectives. So many cases I just run review spec like with 5 parallel agents. All of them gets kind of different sub-persona. And this way I can find issues much quickly. Because another issue was, for example, but it's more like a loop optimization problem, that the agent find like one race condition in the code. Then in that round it fixed it. Then the reviewer found another race condition, and it was a bit frustrating that we keep finding very similar issues. So in that case, for example, I leveraged the same concept in a way that I asked the agent to classify all the findings that they found in the first round, or by the first few sub-agents. And then if those issues fall into one very classical error category, then it runs a sub-agent to check the change from that specific perspective. And this way I can find more issues much quicker. So just a few words about harness design. Again, I don't want to go into too much detail, but from that article I mentioned, I really like this picture. So one of the most important aspects when you create a harness that you really need to think about to design the guidance and the feedback that you provide to the agent, because this is actually the harness, or a huge part of the harness is just what type of help do you give to the agent to make sure that they can do a good job in the first round and in the upcoming rounds. And of course, you need to generate a lot of feedback loops. And I can tell you that I still found not just some, I still found some bugs in the code generated by the AI. But actually, those are some bugs that I also created as a human. So, and I had some colleagues who also created that type of bugs. But in most of the cases, it was very clear that I was able to create one specific feedback loop for that specific case, then the agent will be able to overcome of that situation on its own. So now I just wanted to share as part of this presentation one interesting topic which I found very, very useful. I'm not sure how much of you used fitness functions. As Raven mentioned, it's very interesting because it's that type of concept which is very old, and nowadays we are kind of re-exploring it because now it makes sense to create well-engineered system, because this is the only way that you can make good progress with AI. So fitness functions are about that you kind of create tests for your architecture or for your code architecture. And I had a very interesting use case. As Yula mentioned, I made a very simple change in Pairflow, and it started to change like 20 files. And this was a reminder that I neglected a bit the code architecture. So I did a redesign, but I was thinking, okay, but how can I avoid that? During the refactoring and after the refactoring, I cannot run into the same situation. And this is, I recalled in my mind, oh, fitness functions, this is what I need here. So this way I was able to create some feedback loop for the code architecture. And what was really cool in this case, that from this point, the harness, and through the harness, the agent also was able to leverage that fitness function. And to give you two very simple examples, two of those fitness functions are a boundary fitness. We just make sure that so some layer of the application cannot reach to some other layer of the application. And there's a dependency fitness functions, which make sure that different type of codes cannot reach out to some other type of codes. And this way, I can make sure that the architectural expectations are held. And even this is something that you can try to put this into like an agents.md, but it wouldn't work. So I have this in my agents.md, but the agent still creating some codes which doesn't fit into. But when it tries to run the test, then it gets a feedback that, hey, do a better job. And what was a very nice experience, so I did the refactoring. It was like 800 commits. It was like a half day. And after 800 commit, I just built the application and it was running without any issue. So it was a very, very nice experience even for me that you can get to this level. And what is also very interesting that you can see in this picture that, and it's a good example that initially I kind of did manually this process. So we did the first quite a lot of refactoring step kind of together with my LLM. And when I started to build the trust in the process and I started to parallelize it, and when I see that this is working, you can see at the end I was using like 8 sub-agents to go crazy, and it just worked. But of course, this wouldn't work if I just ask 6 sub-agents, hey, go and do this refactoring. That would run into a disaster. So this is a good reminder that still engineering mindset and architectural mindset is still very important, at least for now. So some closing thoughts. First, what this harness did by me. I can frame this in a way that I'm kind of trading tokens to manage risk, to increase the rate of success. For me, it was very important to save my attention, because if I'm working in the loop, then it means that I'm interrupted much more. But now I can delegate a huge chunk of the work, which is kind of mechanical, repeatable, and I only need to put my attention into the results when it's kind of really ready. And of course, I learned a lot. So it was I think you hear this from many people nowadays on X or Twitter or whatever, that they kind of started to do engineering work again because it's just so enjoyable. Some results. Of course, I want to highlight that this was the best week. But I was delivering more than 100 user stories, and this is a real application. I'm working now on a legal tech startup project, and I was doing some other stuff. But this was the point where, as Yula mentioned, this was more like I was the limit in the process. So my mental capacity to be able to create task file, to be able to validate the code, because after each task I literally validated, what was created. Especially that at that point when I was doing this, I had a bit less trust in my system. And it is very important that this is not a vibe-coded experience. So it was a decent engineering work. Of course, we can argue that the created code is maybe not the best, but this is where, for example, you can use fitness functions to steer what type of code is created. And I'm quite sure that at the Ustream time, it took like at least 2-3 weeks for a small team to deliver as many stuff. And I'm not sharing this like to brag. I'm sharing it just to show you that what is the potential if you start investing into this direction. And what is also very important, that even my current system is kind of the dumbest from a future perspective. And there are huge amount of ideas and ways to improve it, to include other parts of the value creation process. Because I think that kind of this mechanism that I described, how I created this agentic workflow, I think the concepts can be used for any type of workflow. So the question is that whether it makes sense for you to invest into a harness. I really wanted to highlight one very, very important topic here, this compounding. Because what is really cool, that now we have that type of intelligence that if we solve a class of issue on the harness level, then it means that all the upcoming developments that will be given. So this way, if you kind of keep improving your harness, then you will have a compounding impact, and you can delegate more, you can get more reliable results, you can expand that workflow area that you can tackle this way. So this can really be like a virtuous cycle. So from my perspective, you definitely need to invest into this type of work. Then it's a good question whether should I build my own or should I just use somebody else's harness. So it's a tricky question because, of course, nowadays we have more and more tools. 3 months ago, maybe it was a bit less. And I'm quite sure that most of the stuff that I'm doing is kind of a waste of time because it will be productized. But still, from a learning perspective, it is super important that I did this work on my own. Because working with LLMs and doing this type of work, I think it's not super intuitive. So you need to build a lot of intuition. And as in the gym, it doesn't work that before summer I go to the gym, I do a few exercises, and I'm in a great shape. You need to do a lot of repetition to build those muscles. And I think from the perspective of how much you value in the future as a software engineer, I think it will be very, very important how good you are in this type of topics. So this is one part. So kind of like my message is that you cannot really wait that somebody will productize it. It makes sense to start building it. But the other aspect is that, so if somebody has a promise that, okay, I have the harness and you just need to install to your system, you can be sure that person is lying or trying to sell something to you, because a huge part of the harness is very specific to your own system, to your own code base, to your own code architecture. And in many cases, you will notice if you start investing into this direction that you kind of, like a DNA spiral, you need to keep improving your architecture, your code base, your harness, your code base, your architecture, your harness, and this is the only way you can make good results. So there is no, I think this is definitely the case when there is no silver bullets. So a few topics that I learned the hard way. Transferring your intent to an LLM sometimes is very hard, as I mentioned, and it can be very frustrating when it just gets some super complicated stuff this easy, and then some simple stuff they just cannot get. So I also invest a lot of time into the specification, into the task. It's very important to read those very carefully, even though you can get into this planning fatigue very easily. What I try to do, or I try to experiment with, that I try to create some kind of visual representation of the plan or visual clues where it's much easier to catch, whether we are on the same page or not. And what I also notice that usually the LLMs are super logical. So if you just hear a sentence and even just one word, it doesn't click, then it makes sense to dig a bit, because usually there is a good chance that you are not on the same page. And if you are not on the same page, then the result will be very different that you want to see. So the code base to the relationship, the relationship with the code base, I think is still very important. I made a mistake a few times that I was not carefully watching, what is happening. And then a few times I learned that even though I thought that my intent was properly delivered to the LLM, but something very different was created than what I expected. So I think from time to time it makes sense to have a reality check. And like in TDD, if the expectations are different than what you wanted to see, then it makes sense to revert and spend some time to really understand, what is in your code base, because otherwise you can get into a very tricky situation. System boundaries are very important. As I mentioned, most of the issues in my case are related when two systems are talking with each other. I'm creating a system where we have Next.js, Edge functions, databases, and some other APIs. And usually, when those parts of the code generates most of the bugs when there is a communication on those boundaries. So try to make those testable or create some kind of feedback loop that can help from this perspective. And my favorite is that frustration is a signal. So when I was the most frustrated with those specification issues, this is where I think I created the most interesting value and the most interesting parts of the system. So if you are frustrated, then maybe go for a walk and then try to think about, okay, but how can I get through this problem out? And what is very, very interesting point, that in many cases you don't really need to think very hardly. You just ask the LLM that, hey, what just happened? And then it will give you an explanation, and then you understand, okay, that this little bastard is thinking this freaky way, and then you can start improving your harness. And the key takeaways from my perspective, so I really like this narrative that we are going from prompts to agents to harness to convergence. So I think it's very important that you invest into your harness, because this is, I think, the only way that you can really leverage LLMs. It's very important to design the guidance and the feedback that you provide to the agents through your harness. And I think it's a very good investment to think about this gradual consistency perspective, because this is where I kind of gained most of the value when I created Pairflow. And it was a very, very important concept for me to understand, and I leveraged it so many ways. Thank you.